This conference will now be recorded.
So welcome everyone to another OCP Tap session. This is the call number 79. Today we have Thomas Behn from Meinberg. Thomas Behn is a senior software engineer at the German synchronization specialist Meinberg, graduating with a Bachelor of Science degree in Business Informatics at the Hochschule Weserbergland in Hamelin in 2011. He jumped straight into a career at Meinberg, where over the course of more than a decade, he has gained a wealth of experience in development of firmware for embedded and standalone time synchronization devices, mostly in C. As well as cross-platform configuration interfaces and other software tools with C and C++. Today, he is responsible for multiple PTP-related projects like the NetSync Monitor, aka reverse PTP, extension for PTP, Meinberg Protocol Simulation, flashptpd, and most importantly, PTP Track Hound. So again, today, as you can see, the presentation is mainly about Track Hound version 2. And one more thing before we give the floor to Thomas is we have a one-off, like basically the next call will be in a week, and then we have also like the week after. So basically just for a one-off or frequency doubles. So so it's basically we have a call by Kevin Stanton, which is basically a deeper dive into PTM. So anything else anyone wants to add before we give the floor to Thomas? Hearing none. Thomas, the floor is yours.
Okay, thanks Ahmad for the introduction, and also thanks for the opportunity to talk about PTP Track Hound here today. Yeah, as Ahmad already said, this is about PTP Track Hound version 2, which we call the central monitoring hub for timing critical infrastructure. First of all, a few basics about the software. PTP Track Hound is a software that allows you to capture, visualize, and analyze PTP network traffic, whether it be version 1, PTP version 2, or 2.1. It's the successor, obviously, of PTP Track Hound version 1. So version 1 has been released in August 2017. We had like 7,000 or 8,000 downloads of version 1 since then. It's been the tool of choice for troubleshooting PTP. Basically for live troubleshooting, it's been used for at many PTP plugfests. At the SMD plugfest, for example, it's been heavily used. Version 2 is available as free download for Windows, Mac, and Linux on ptptrackhound.com. All you need to do is enter your email address and your name and company, and you will get an email with the download links for all the platforms. The main difference, or one of the main differences of version 2 compared to version 1 is that version 2 now offers a standalone capture service. So you can run the capture service together with the OS, leave the UI closed, and just let the capture service run. And whenever something happens, you can connect to the web interface or to the REST API and yeah, see what happened and get into action. In version 1, this was different. Version 1 was a monolithic application, so you had to start the capture together with the UI, and when you closed the UI, the capture was automatically stopped, just like Wireshark. From version 2.1, which will be released in a couple of weeks, I would say, there will be 4 different combinable ways in PTP Track Hound to monitor and or measure the performance of PTP networks. I will talk about these 4 ways in a couple of slides. You also have advanced monitoring features like SNMP traps, email notifications, internal syslog or external syslog messages. So whenever something happens in the network, for example, the port state of a device changes, then you can be notified about that and can connect to the web UI and see what happened. And we also have a feature we call multi-site monitoring. I will also talk about that later. It basically makes it possible to capture in front and behind a boundary clock and collect the data and show it in one topology, because obviously, as it's called a boundary clock, you won't see the traffic. If you connect behind the boundary clock, you won't see the traffic from the grandmaster. So you need to combine the capture somehow. And PTP Track Hound comes with 3 different single-user license options. The first one is the free version, which you can download from the website, and then we have a basic and a professional license, which you can buy from us. And these allow you to use the enhanced monitoring features. So with the free version, you will only be able to use it like version 1 mainly. So use it for troubleshooting, but not for the real monitoring part of it. So summarizing, you could say that while version 1 was really a replacement for capturing tools like Wireshark, version 2 is now the central monitoring hub for your infrastructure. Yeah, a little introduction into the terminology being used in PTP Track Hound. I want to introduce these 4 terms which are heavily used in PTP Track Hound. The first term is the scope. Scope is in Track Hound is a unique combination of a network segment, which I will talk about next. The PTP version 1 or version 2 or 2.1, the subdomain or domain number, the networking protocol that's being used in the scope, and the VLAN ID tag if there's any. So, for example, PTP version 2, domain 0, IPv4 without a VLAN, that would be one combination for a scope. That would be one scope. And this is necessary to allow for multiple grandmasters acting in different domains, for example. Then each of the domains would be one scope in PTP Track Hound. And to make it even worse, it's possible, of course, if you have 2 capture interfaces, for example, and capture in 2 different networks, it's possible that you get the same scope in both networks. And that's why we introduced segments as well. So you can assign a segment ID to a capture interface. And by doing that, you allow scopes to be broken down into different groups, so that you can have a version 2 domain 0 IPv4 scope in both networks without Track Hound thinking that you have 2 active grandmaster clocks in one unique scope. I will show you in the live demo what this is about. Without segments, all devices, instances, and scopes are assumed to be running within the same singular network. So that's why we need this. Then we have devices. The device is detected and identified by its unique PTP clock ID. As you may know, each PTP packet contains the PTP clock ID of the sender. So with that, we can identify the device that's being sending the packets. Then we have a type for each device. This is kind of estimated, of course, because we only see the instances that are running on the device, and by interpreting this, we can make an assumption on the type of the device. In most cases, a grandmaster clock will only have one instance, while a boundary clock may have multiple time transmitter instances running on different ports. And the time receiver clock will only send delay requests. That's kind of the thing we do in that case. And each device has a configurable set of metadata, so you can add your own vendor name, you can upload images of the device, you can set hardware, software, firmware revision, and some other things I will show you in the live demo as well. And then we have, as a fourth term, we have the instance. The instance defines a singular PTP session running on any given device. So one device can run multiple instances concurrently, just like a boundary clock, for example. If you have a boundary clock with 24 ports and all of them are connected, you will probably see 24 instances, 23 running as a time transmitter and 1 running as a time receiver. Each instance has its own specific scope. So yeah, an instance is always assigned to a scope because yeah, if a PTP instance is running, it will run, for example, PTP version 2 in domain 0 with IPv4, and that will be its scope. Okay, as I said, there's 4 ways. There are 4 ways in PTP Track Hound to make sure that your infrastructure is in sync. The one that has always been there is the way number 1, passive monitoring. That means, yeah, passively capturing and analyzing the PTP traffic. That's what PTP Track Hound has always been doing. Then we have a second way, which we've added since version 2. This is the active monitoring. That means we are sending PTP management messages in periodic, in configurable periodics, and we request the common PTP datasets from instances within the monitored network. So by doing that, we can gain a lot more information about the instances we may already have detected with way number 1. And also we can not only make assumptions on the state or on the type of the devices, but we can let the devices report its state. Then we added a third way in version 2.05, which we call passive measurement or capture time offsets. With capture time offsets, we compare the timestamps of incoming PTP sync messages or corresponding follow-up messages with the local capture timestamps. As you may know, libpcap offers hardware timestamps, so you can enable hardware timestamps for captured packets, and you will then have a precise timestamp for the capture time of the packet, and can then subtract the transmit timestamp of the sync message from the capture timestamp, and that's exactly the offset together with the pass delay. I will talk about CTO in detail on the next slide. And the fourth way, which we will add with version 2.1 coming soon, will be active measurements, and that's periodical transmission of NetSync Monitor or reverse PTP requests to actively measure pass delays and clock offsets. So that's kind of a it's not really a new way, but it's a new way in PTP Track Hound. We've been doing this since a lot of years in our LAN time firmware. It's a special mechanism which we developed, and a few other developers of PTP software have already added this as well. So I will give you an introduction to this as well on the next slides. Okay, as I said, a few more words about capture time offset. As I already said, it's a comparison between the timestamps of sync and follow-up messages and the corresponding capture timestamp of the sync message. And this enables you to detect problems on devices that transmit time, like grandmaster and boundary clocks, as well as issues with the network itself. So the CTO, as I said already, includes the pass delay. So if something changes in the CTO, for example, if you see a big change from one CTO compared to the one measured immediately prior, then if there's a big change, you can be sure that either there's been a step in the grandmaster or boundary clock, or something changed in the network. So one of these two things must have happened. Of course, the clock that provides the capture timestamp, in that case the network adapter of the system running PTP Track Hound, must be synchronized, and that synchronization as of yet is not part of PTP Track Hound, but we are already working on that. So we also want to integrate the synchronization of the timestamper to the software. At the moment, you need to run PTP4L on for example, and synchronize the hardware timestamper, and then use the hardware timestamps to have precise capture timestamps. And then we calculate a delta between one measured CTO and the CTO measured immediately prior, so that you can immediately see clock drifts or changes in the network. And we have configurable thresholds, so you can say, for example, whenever the CTO delta is above 20 nanoseconds, I want to get an alarm, and then you can check what happened. Sorry. And a short example on CTO at the bottom of this slide, you can see two sync follow-up sequences. CTO1 is we only take the nanoseconds parts of the timestamps now, because the seconds obviously are always the same. CTO1 is the part of the follow-up timestamp minus the part of the capture timestamp, and that's minus 5.9 microseconds. CTO2 is the same timestamps, and then you get to minus 6.0 microseconds, and the delta between the two is 0.026 microseconds, 26 nanoseconds. That's how capture time offsets work. And yeah, as I already said, there will be a fourth way coming with version 2.1, NetSync Monitor. The monitored device, in this case PTP Track Hound, sends a delay request together with a special TLV, special monitoring TLV we've defined by ourselves. And the monitored device which supports this mechanism will respond with a delay response plus that TLV and a sync and a follow-up message if it's a two-step clock. And with this mechanism, we have all four timestamps, and we can calculate the path delay and the offset of the device. The monitoring TLV contains additional information about the sync state, mainly the PTP data sets. You can also collect with PTP management messages. So that's just for additional reporting information from the device. One of the main benefits, or one of the main advantages of this mechanism, is that we didn't need to define new message formats, but we are only using well-known PTP messages: delay request, delay response, sync, and follow-ups. This mechanism is as of now, supported by us, of course, so by our IMS cards, by the SyncBox N2X, a microsync, and also by our Meinberg PTP client software. It's also supported by Oregano PTP-aware devices, so switches, the PCI Express card they offer. It's supported by SolarFlare PTP adapters on Linux. They have this special fork of PTPD, which they call SFPTPD, and they integrated the mechanism as well. And it's also supported in Grayware Domain Time 2, which is a PTP client for Windows. And from my point of view, most importantly, it's supported by PTP4L. So whenever you use PTP4L, you can also use this mechanism. If you want to learn more about this, or are interested in implementing this into your devices or software or whatever, please ask us for the specifications. We have a PDF document which explains this pretty clearly. Okay, a few more words about multi-site monitoring. Multi-site monitoring, as I already said, allows you to capture traffic in in different segments of a network or in different networks, for example, in different tiers of a 3-tier architecture, before and behind a boundary clock, all kinds of things you can imagine where you don't have access to the network segment or network on that PC where you're running the one central PTP Track Hound instance. The captured traffic can then be forwarded to one or more central collection instances. So you can, for example, run 3 remote capture services of PTP Track Hound in different parts of your network and let them forward all the traffic to one central instance. And that central instance will then capture and analyze the forwarded traffic as if it had been captured on its own network interfaces. So it will look like this central instance would have captured all the traffic, and it will show the whole topology of the network. You can see grandmaster clock, the boundary clocks, and all the time receiver clocks from top to bottom. And for the remote capture devices, you can also encrypt the forwarded traffic if you want to. For example, if you need to forward it on a public way with pre-shared keys. And you can disable the evaluation and analysis of the incoming traffic on that remote capture services so that they only forward the traffic and will then drop it so that these remote capture services would be pretty lightweight. They don't need any RAM or so. They just see the traffic, forward it, and delete it. Just a very short summary about the license options we have. The main difference between the basic and the free version is that you can connect to the web interface from remote as well in the basic version. In the free version, you will only be allowed to access the web interface from localhost. And the basic version allows you to run this previously mentioned remote capture service. So you can run the remote capture with the basic license. For the data collection instance, you need the professional license. And in addition to that, the professional version allows you to send management messages, to do capture time offsets, to send notifications, the REST API, and also this version 2.1 NetSync monitoring. Okay, that's all for the theory part of my talk. I have prepared a little test network. We have a LANtime M4000 running as a grandmaster clock. Then we have a Oregano transparent clock and a couple of receiver clocks. One Meinberg microsync running as a time receiver. Then 3 PC engines, single board computers running PTP-4L. Latte Panda Sigma, which is pretty powerful, what they call the single board server. Also running PTP-4L, and then we have my HP Z2 workstation, which is my work PC. This one's running PTP Track Hound and also our NTP PTP simulator MPS version 2, which we use to simulate traffic to generate PTP traffic. Okay, let's go to PTP Track Hound. You should now see the web interface, right? Okay, good. So I log in with the default credentials, Track Hound, password is woof. And yeah, what you can see first is that the top status bar, the current capture status is that no capture interface has been selected. So that's also why at the moment we see 0 scopes, 0 devices, no messages at all. Memory usage is only 16 megabytes. So first thing we do is we go to settings and enable the network interface, which is connected to my test setup. And I also assign a segment ID, in this case, segment ID 0. I will tell you later why. And then I click apply. And now we should see that the live capture is running on this interface. And we already found 1 scope, 10 devices, 10 instances running on these 10 devices, and the number of messages is already counting up. So back to the dashboard. In the dashboard, we see the traffic overview, the recent announce messages. We can have a look into the announce messages being sent by the Grandmaster. We can see, for example, the clock quality parameters of the clock. It's clock class 6, so that means it's synchronized to GPS. That's the time source part of the announce message. We can also see a couple of statistics, the total packet count that has been captured, and a few statistics of packets per second, one announce per second, one sync per second, and so on. On the right side, we see the scopes that have been detected. In this case, it's one scope in one segment. My segment is my segment with the ID 0, and I can give a name for that segment, and I can also describe my segment. In this case, it's my the network on my desk. On my desk, so that's a pretty small network. We will see a bigger network later. Okay, then we get a first overview of all vendors that have been detected. We have 10 devices from 7 vendors. One of the vendors is Meinberg, of course. Then we have PC Engines, the single board computer vendor, Latte Panda, and the other vendors are vendors that I simulate with the MPS version 2. And we also get an overview of the memory that's being used by Track Hound and the recent events, which is by now only capture has been started. Okay, first one of the most important views for troubleshooting. This is probably what you know from Wireshark. So this pretty much looks like Wireshark. You see the current PTP messages that are being captured. I have the option to filter these. Of course, at the moment we only have one scope, so I cannot filter by scope, but I can filter by packet type. For example, I only want to see sync and follow-up messages. Then this will immediately show me only sync and follow-ups. And I can disable the auto scrolling, so that means it will not automatically scroll to the most recent messages, and then I can have a detailed look into the messages, just like you can have them in Wireshark as well, the different parts of the protocol headers and also the metadata or the payload that is being added to the packets. So, for example, the timestamp of the sync message or the timestamp of the follow-up message. And you can also hover the parts and see the hex data of the packet. On the right side of this view, you get some more statistics, the total number of packets that have been captured, announce messages, sync messages, just a little bit more advanced than on the dashboard. And you also see the throughput. So at the moment, it's 16.5 kilobits per second being used for PTP in this network. And you also see a history of throughput or PTP version packets or whatever you want to choose here. You can, for example, also see the development of announce messages, but this is of course 1 per second, and it's been 1 per second all the time. Okay, next view of PTP Track Hound is the scopes view. This is at the moment there's only one segment and one scope. So the scope is PTP version 2, domain 0, IPv4, no VLAN. And in that scope we have one grandmaster clock and 9 time receivers. There's different ways to show this, of course. So you can have this tree view, or you can also switch to a topology graph. So it looks like this. We have the Meinberg Grandmaster and the time receiver clocks here. But let me go to the settings and enable a second interface so that you can see what the network segments are about. So I will just add a second interface as a capture interface, and I will assign segment ID 1 to this interface. Now the capture is being restarted, and if I go back to scopes, we should now see that we have 2 segments. So in this case, it's my DeskNet on the left side, and it's the Meinberg development network on the right side. This is a combined network of different people working for Meinberg. They have devices on their desks, of course, and you can see that a lot of PTP traffic is going on there. We have multiple domains, and each of these domains is one scope in PTP Track Hound. Okay, but for now, let's concentrate on only the test network. So I will disable the second interface again. And to hide the segment which has been found before, we have to erase the captured data. And then we will only have the DeskNet again. In the scope, you can see that the current grandmaster is the Meinberg grandmaster. You can also get some information about the quality of the grandmaster. If there would be a second grandmaster running in that scope, that would be marked as an illegal grandmaster, and it would be red, and it would also be shown here. We always do that at the ISPCS Plugfest. We add rogue masters, and that's always a good test for time receivers to make sure that they synchronize to the correct master. And PTP Track Hound will immediately show why the illegal master is illegal. So it will mark the clock quality field. For example, if that one would have clock class 7, this field would be red, and you could see that that's the reason for this grandmaster being illegal. If you click on one of the instances, you can also get additional information. In this case, for example, the vendor, the port identity, which delay mechanism is being used, more about the clock quality, the time scale, UTC offset, and also a message count for each instance. That's some additional information you can get in the scopes view. Next view is the devices view. In the devices view, we have the nice device map. So another possibility to show a PTP network is this one. We have the one grandmaster clock and the 9 receiver clocks around. In this case, it's only 7 because the PC engines are combined. The 3 receiver clocks are shown as 1. And on the right side, you get a list of all the devices, and you can open the devices. You can also open them by clicking on the devices in the map. And as I said already, you can configure all types of additional information. For example, well, I don't have to configure Meinberg because that has already been detected by the clock ID, but I could, for example, configure that this is a LAN time M4000. I could also upload an image of the device. So in that case, we wouldn't see the Meinberg logo in the network map any longer, but the real device. And we could do the same, for example, for the Meinberg receiver clock. This is the microsync. So we can say this is the microsync RX. And we can import another picture so that now the microsync will also be shown in the network graph. And we also see the model of the device in the map at the bottom of this box. Okay, that's all about the devices view and the customization options. Then this last view, this analysis view, is all new in version 2.1. This will be combined statistics that can be gained in the 4 ways I previously mentioned, or in the 3 ways, because passive capture doesn't create any statistics. But if you send management messages, that would be reported offset and delay, and always a delta of the one offset and the previous offset. Then we have measured offset and delay, which is the NetSync Monitor feature. And then we have the CTO, which is the capture time offset. So at the moment we only use the way 1, which I introduced. So we will now enable management messages, which would be what we call active monitoring, way number 2, and we decrease the interval so that we create a lot of data for now. You can say, for example, only send management messages to via protocol IPv4 and only in version 2 and only to PTP domain 0, because otherwise PTP Track Hound would try to send to all domains, send to all versions, send to all protocols, and that would of course generate a lot of traffic that would not be needed for now. And you can also choose if you want to loop back the generated messages, so if you want to see them in PTP Track Hound or not. In this case, I just leave it like this. Okay. The capture is being restarted, and now we send management messages every 15 seconds. And every 15 seconds, the instances in our domain 0 IPv4 PTP-v2 scope will respond with their PTP common data sets, like the PTP current data set, which contains the current offset and also the mean pass delay. So now you see that we got a few checkboxes here. We can now select one of the time receiver clocks. For example, I will now select the microsync, and you see that we already have 3 points in the graph, so that we already got 3 reported offsets, -4 nanoseconds to +1 nanoseconds, which is a pretty small value. We can also see the delta. So of course, if it was -4 and it went to 1, that's 5 as a delta. Then it went back to -2. The delta is 3. So that's how the delta works. We can also show the reported delay, the pass delay. So the device reports it has a pass delay of 42 nanoseconds, 47 nanoseconds, which is possible because we have a transparent clock in between, which compensates for the residence time of the packet. So the pass delay is really only the length of the Ethernet cables. That's for the reported offsets. Then we have, as I said, the third way to get more information about the offsets of a device, and that's the time to enable capture time offsets. So now we can say enable capture time offsets. We can also set a threshold and a threshold for the delta. We will leave it like this for now. And we need to enable hardware timestamps for that capture interface, because otherwise the capture time offsets will be something 100 or 200 microseconds, because we only have software timestamps. Okay, and now what Track Hound does is every time it receives a sync message from the device, it will calculate the capture time offset. So that's that should generate much more data than every 15 seconds. It's 1 CTO measurement per second. You can see that there's already a lot of measurements inside. In this case, the capture time offset is around 440 to 340 nanoseconds. So that includes the pass delay and the offset of the GM compared to the local capture interface. And we can also show the delta between one CTO and the prior CTO, which is, from my point of view, the most important figure, because whenever this changes, there's definitely a big change either on the grandmaster or in the network. Because this is the difference between one follow-up sequence and the next one. The fourth way, as I said, is NetSync Monitor. We can also enable this one. so that we have all 4 ways enabled. You have the selection to either monitor all known nodes. So all known nodes will be requested with this special delay request, or you can mention specific nodes that shall be monitored with this way. And I will do that for now. I will specify 2 IP addresses, which shall be requested every 4 seconds. And we will then see that some data will be generated for these instances. Okay, so these 2 IP addresses will be requested every 4 seconds. We should also see the new measurements in the scopes view. In the scopes view, you have one offset column, which was empty when I showed you this view the last time, but now you can already see that we have a couple of NSM, NetSync Monitor offsets, and also the CTO value and the management value. In this case, NSM shows a difference of 37 seconds, which is pretty much the UTC offset. So let's ignore that for now. I think it's the problem with PhD to this on my PC. I have to specify the offset that shall be used. So for now, let's focus on the delta of the NetSync monitor. Disable CTO first, and then I can enable the offset. You can see that this is, yeah, of course, this range is now not really helpful, but it's within a couple of nanoseconds. I can show you the delta for both NetSync monitor measurements, and you can see that, yeah, it's been 5 microseconds, 20 microseconds, Okay, there's something going on with my PTP network, I think. Normally, this should be yeah, tens of nanoseconds or so. I would think that right now the network interface I'm using for doing this measurements is not well synchronized or so. Anyway, doesn't matter for now. I can show you that that you can do all this this stuff and that you can show the graphs and so on. Okay. I think that's all for analysis and measurements. The last part I would like to show you is the CTO thresholds. Let's go back to the analysis and see what the values are. So we have around 400 nanoseconds CTO and up to 18 nanoseconds delta. So I would set 420 nanoseconds as the CTO threshold and let's say 16 nanoseconds as a threshold for delta because we now want to generate some events. I save this and we should now immediately see in the dashboard that a couple of events are created. So now you see that there's a warning, capture time offset delta threshold exceeded, and also capture time offset delta normalized. So yeah, that's already events that are being generated because the threshold has exceeded and the threshold has yeah, the value is below the threshold again. And based on that, you can then let PTP Track Hound send, for example, send emails. You can configure a smart host for SMTP, for example, and yeah, of course, you need to enter a sender address and a recipient address, and you can then choose which triggers of events should be used for this channel. So, for example, I want to generate emails for all the CTO events. And okay, I forgot one click. And now, whenever one of these CTO events happens, For example, now I should see in my inbox, yeah, I got emails about this event has happened. So PTP Track Hound warning, capture time offset delta threshold exceeded. The delta was 70 nanoseconds, which is bigger than 60 nanoseconds. And that's, yeah, that's a problem for me. So I can now get into action and see why that happened. Of course, this threshold is not really, does not really make sense, but that's just an example to generate some data here. Okay, I think that's mainly everything I wanted to show you. So that leaves us like 15 minutes room for questions if you have some.
Thank you, Thomas. So let's open the floor for questions. Any questions? Dan, you want to ask a question? Maybe I can start with one. So Thomas, let's say I have my existing network that is composed from all transparent clocks, and I have, let's say, the time card on top and all of these things. So now I want to, let's say, incorporate your system in my existing network. So first of all, what do I need on every node? Like basically, what's overhead? I'm assuming you have some daemon, right, or something like that, right?
Yeah, it depends on what you want to do. So if you want to use this NetSync Monitor, this real measurement things, then you need to support the mechanism in your software. If you're running PTP4L, it's already in there. If you're running something else, then you have to integrate this. For Track Hound itself, you don't need to support anything on your side. It's basically running passively in the background and capturing the standard PTP traffic. So with the basic version, with the thing only capturing traffic, that's working on each and every PTP network you have. So you don't need to support something for that.
And in terms of hardware, do I need like I mean, something specific connected, or it's just one machine that gets designated?
Yes, it's basically just one machine. You can use Ubuntu, Windows, Linux, whatever, Mac. Of course, if you want to have the accurate measurements, if you want to do the CTO stuff or the NetSync Monitor stuff with hardware timestamping, then you need a Linux system. And you should consider to have two network interfaces which support hardware timestamps, because one can run PTP on a dedicated path to a grandmaster and synchronize itself, and then you can use PHD to this to synchronize the other one and use that one for capture. In this case, in my workstation, I have a Intel i350, I think, which is the one with the 4 ports. And I synchronize one of them on a dedicated link to a grandmaster, and then I use PHD to this to synchronize all the others and use them in PTP Track Hound. So then I have an accurate time source for the measurements. Okay, does that answer your question?
Yes, yes.
Okay.
Vipin, you have a question? You're muted. You're still muted. You're muted. While waiting for Vipin to enable, so this is not a free product, right? Just Thomas, just
Yes.
Vipin, good.
Hey, hi Ahmed. Hi Thomas. Thanks for presenting. Actually, so I am from SyncMong Technology, Bangalore, India, and thanks for presenting it here. Actually, so we also have on the similar line, we have a solution on the fisheye, and we keep on seeing some of the queries from the customers and people saying that Let's say that in the network we want to monitor, and the monitor need to have, there are a lot of already deployed solutions like the Cisco, Junipers, and maybe the Broadcom Marvell solutions actually. How we go and monitor those nodes when we are talking about the monitoring of real monitoring of those solutions, that nodes, what is happening in my network. I can monitor the grandmaster, I can monitor my end node where I have implemented this, where I have integrated the solutions like this. But how we will go and monitor the nodes which is already in the field actually, which is already in present actually, until and unless like say the Juniper or Cisco or these kind of vendors open up and say that yes, we are ready with the some of the network protocol or specifications, they go and adhere to that. How we go and solve the problem. So we also face this issues, and I feel that thing that community need to come up and say that these are the standards which that all the vendors should have implemented, so that the monitoring can happen. And because we see that thing in the when we will be the all the nodes will be having the PTP aware, and the network will be need to be monitored, and we need to monitor which node has gone rogue actually, how that your system has gone bad actually. So that how we see that thing, like how we can go and implement that thing for each and every node actually. So because monitoring is not only the monitoring grandmaster and monitoring the last mile node actually. You may have to monitor the full network and take the corrective actions if there is something wrong is happening. So that is what the problem we also face, and we also face a lot of problem. We have solutions there, but how we will go and integrate solutions with the already existing network elements?
Yeah, thanks for the question. That's a good question. One thing, Cisco, Arista, these kind of boundary clock vendors, I would say, we've contacted them. We want them to support this NetSync Monitor measurements, and they have been open for it, but yeah, PTP, of course, is a small topic for them, and it takes time. I know that Arista works on it. Maybe they have something for the switches in the future, but yeah, you can never be sure. The second thing with PTP Track Hound, with this capture time offsets, the special thing about this is there's no support needed by anyone. If a Cisco switch, for example, runs in a boundary clock mode, and it acts as a time transmitter in the network, then you can use the CTO to measure the time coming from the device. If you are synchronizing your track hound interface and get the sync messages in and then compare the capture timestamps, that's a real measurement which is already supported by them, because they have to send out sync and follow-up messages if they run as a time transmitter. Yeah, and this third thing, management messages, most of the vendors support management messages as well. So the reports can be used. Yeah, but as I said already, it's only reports, so you can never be sure if the device that reports something reports the correct information. So yeah, I would rather go with measurements, and that's why I really like the CTO feature, because that's something that doesn't need any support from the devices that you want to measure.
Sure, yeah, thanks for that.
You're welcome.
So
Thanks.
one thing I was just thinking, maybe it would be useful to have, let's say, a set of standard interfaces that are like, let's say, will be openly available, let's say, for those switches, that, let's say, if TrackHound or whatever, let's say SyncMonk, or I don't know, whatever VPN the product is named, or some other products in the future, or some open source version of things show up, they can all use those, like, you know, available interface. I think that you probably can do that via OCP, because then it'll be like a community request. Yeah.
Yeah, that's what. Yeah. So our product name is Fisheye.
Yeah.
Our product name is Fisheye. Just to that, maybe like if Ahmad will allow us, like we will present it in some time in some slot for the better community.
And I think it will be also good if you let's say you guys reach out directly to Meinberg, work with Thomas, and I think Thomas, you guys, I'm pretty sure you guys are like welcoming it. Discuss like what are the, let's say, bare minimum standards, like let's say sockets or whatever you want to have from the switch vendors. Then perhaps we can have it, we can follow the dialogue via OCP to those vendors and have some standardization there, so it makes things much smoother as to go forward. Does that make sense?
Yeah, that
Yes,
would be
yeah.
great. Yeah, I mean, we have the specs already for the NetSync Monitor. It's a PDF document, 10 sites or 10 pages or so. Yeah, if we can just send these to them and they come on
Would you
integrate
mind?
it.
Yeah, would you mind sending it to me, and then I can share it back? Let's say we can have email thread, and whoever else is interested, we can get all people along. Maybe we can turn it to a they call it a basic spec, I think, as an OCP contribution, and then we go back to the vendors, and then we say, hey, let's if possible, let's adhere to this. So then they don't need to, let's say, make something specific for Meinberg, and then next day for something else, and for that, because guess what? If that's the case, they will not do it. But if there is one thing that's available to everyone, then yeah, they do the investment easy on it, because then everyone can use the same thing.
Yeah, of course. Sounds good.
Great. I'll wait for you to send me like whatever document you have, and we can roll on that.
Yeah, I will do.
Any more questions? All right. Hearing none, then thank you again, Thomas, for your great presentation and demo. And we'll see everyone next week. Again, as I said, like the frequency doubles on a one-off. So we're going to have a presentation by Kevin Stanton, but more deep dive in PTM.
Thank you.
And see you guys next week. Bye, everyone.
Bye.